Hi again, pre-calcers. Time for lesson 5-6, the law of sines. And I know some of you were using this in an earlier lesson to try to solve a right triangle. And as you can see, primarily this law of sines is used for non-right triangles, although when you did use it on right triangles, you were correct. The main times we use the law of sines is with these two conditions: angle side angle or angle angle side. So in other words, two angles and a side. And later on we'll see another time when we use the law of sines called the ambiguous case. And the law of sines is nice to use because it's so easy to remember. Basically it's the sine of an angle over the length of the opposite side. And the law is actually written like this with three different ratios, but you just need to use any two of the three to find your missing side or angle or to solve that triangle. Alright, let's take a look at an example of how this might work out here. So here's our example 1. Solve triangle LMN. If L is 29, M is 112, and side L is 22. It's always good. First step is to draw the triangle, and if you can draw it sort of to scale like that, that's helpful but not necessary. I'll write it like this: LMN, and what we're given then is this angle M is fairly big at 112, and L is at 29, and side L, which would be across from angle L, then is 22. So the condition we're given here then is angle angle side, and that's tailor-made then for the law of sines. So if I'm going to go ahead and solve this, then I would say the sine of 29 over 22 will equal the sine of 112 over little side m. And of course you can do some cross multiplying here. Basically you would multiply these two, 22 times the sine of 112. That would equal m times the sine of 29. But if you're solving for m, it basically ends up to be this times this, 22 times the sine of 112, and then divided by that. And if you do that, you will get that side m is about 42.1. You should try this on your calculator just to make sure that you can get that same answer like that. And then the next thing we'll need to do is we just need to find side n. By the way, our other missing side here, or excuse me, our other missing angle would be 39 degrees. That obtained by the sum of all the angles in a triangle equaling 180. And lastly then, we would take that same first ratio then, the sine of 29 over 22, but this time then it will equal the sine of 39, that's that angle we just mentioned there, over side n. Once again we do our cross multiplying, and n would end up to be 28.6. So there's a pretty easy example for the law of sines to use in sort of a real life situation. So let's say that Raina is riding in her hot air balloon and observes that the angle of depression to the green giant statue is 65 degrees. And then she goes up 500 more feet, and now the angle of depression is 70 degrees. So how far is she from the green giant statue now, GGS? Well, first of all, let's kind of draw this out a bit, see if we can decipher what's going on here. So first of all, her angle of depression when she's here going down to the green giant. Now the angle of depression, remember, is actually this angle here, so it'd be this angle with the horizon here. So I'm just going to write this, draw this a little bit different, kind of a dashed line, and the 65 degrees then would actually be like this. So we may not use that 65 degrees per se. Then she's going to go up another 500 feet. So this is 500 right here. And then her next angle of depression then, looking down again to the green giant, this angle, again the angle of depression would not be the actual angle of the triangle, but that's going to be 70 degrees right in here. So if we think about the angles we're going to use for this particular triangle, the one of them that we want is going to be right in here. That's not going to be 70, but we're going to use 20 degrees because it does form a right angle in here, and actually the one that's part of the triangle would actually be the 20 degrees. And then another part that's a little bit tricky is this angle in here. The angle of depression is 65, but the entire angle that we want here is going to be 90 plus 65, in other words 155 degrees. That's the other angle we'll use. And what we're really trying to find then is this side D that runs the entire length from where Raina is at her highest height all the way down to that green giant statue. And so once again you see that we have two angles and a side basically. This one would be more of the side angle variety, but still trying to find this missing side here. And so once again I would, this time I'm only looking for this particular side, so I only have to go through my law of sines once. And so it's going to look something like this. By the way, my other angle down here then would be a mere 5 degrees if we add up all the other angles that we know. So I'm going to say it's going to be the sine of 5 degrees over 500. That's actually the opposite side of that 5 degrees. And then that's going to equal the sine of 155. That's this big angle right here, over the side that I'm trying to find, which is that side D. I do my cross multiplying, 500 times the sine of 155, dividing it by the sine of 5, and I get this, 2,424 feet. So that is how far Raina is from the green giant statue. So way to go, Raina. Alright, so we're going to go on to our here. You probably remember what the formula for the area of a triangle is, and that's something that you learned about quite at a young age, I'm sure. Area equals 1/2 base times height, and that's one that still works. You can use that a lot, and especially useful if you know what that height is. However, sometimes it's a bit of a pain to do that, and trigonometry allows us to derive another formula for the area of a triangle. What we've talked about in this chapter, just some basic right triangle trig here, is if I look at angle C here, I can say that the sine of angle C is going to be opposite over hypotenuse. So in this case, that's going to be h over a. And actually the h then, I can solve for that. If I solve for h, I'm going to get a times the sine of c is going to be h. Well, what if I made that substitution in my familiar area of a triangle formula? I'm going to put whatever h is equal here, I'm going to plop that in place of this h. So I'm going to put this a sine c in place of this h. So then it's essentially going to look like the area equaling 1/2 base, but instead of h I'm going to put in a sine c. And I'm just going to rewrite this a little bit so it looks prettier. 1/2 ab sine c. That's going to be my new formula for the area of a triangle. And notice the nice part about that is what this enables me to do is find the area of a triangle if I just know two sides and the angle between it. So a side angle side situation, if I know that, I can now find the area of a triangle. So next example. So here's my triangle here. I'm going to again draw a little diagram here best I can. So I have triangle ABC, something like this perhaps. Again, it doesn't have to be drawn to scale too much. And we know that side B is 21, so that's going to be down here. Side C is 16. and then angle A is 25. So again, this one is set up beautifully to help us find the area of a triangle, because sure enough we have this side angle side situation. So if I go ahead and try to calculate this out according to my new formula now, area equals 1/2. Now instead of base times height, I just use my two sides. So it's going to be 16 times 21 times the sine of that included angle, which is 25 degrees in this case. And if I multiply that out, easy enough, I get about 71 square units. So, pretty nice way to find the area of a triangle using some trigonometry. So anyway, stuff on the law of sines, and remember that it's the law and it works really well. All right, thanks for listening, everybody, and we'll see you guys in class.